Hello, welcome to another supplemental help video. Today we are going to be going over lesson 12, which is for loops and other iterable objects. So an iterable object is something that we can tell a for loop that I want you to go through this thing and I want you to loop through every individual item. So let's take a look at what that might look like. So I'm going to have a list here. I'm going to have a list of foods. We'll say that there is apple in this list. We'll say there's an orange in this list. We'll say there's cucumber in this list, and we'll say that there is a pineapple. All right, so we have a few different things in this list. We have four different things, and now I can actually use a for loop. So again, we're going to start with that for I in, and this time we're going to say, instead of range, we're going to say food. And I'm going to print out I. And the behavior that we can expect now is I can expect my program to actually run and go through every single item in food and print them all out individually. So every single time my for loop ran, I got apple in it. Then the next time it ran, it got orange in it, then cucumber, then pineapple, and so on and so forth. So this is different, by the way, than just printing out food, right? Because I can print out food, and that does an okay job, right? But these really give it to every single one of these to me individually, which is super nice. So that is one thing that we can do with our loops in Python. We can actually go through a list. Now, here is the big thing. We are going to return to a very old friend of ours. We are going to get Turtle back involved because now we can actually do some really, really cool things. So if you recall before, I used turtle.forward 100 and turtle.left 90, right? And I copied and pasted this three times in total. So we're going to get rid of our for loop here for just a moment, all right? And if I run this, all right, I get myself a square, right? That's pretty easy. But take a look at what I've just done. This is the same thing four times over. So what am I doing? This is harder than, say, using a for I in range 4. So this is going to run 4 times. I'm going to tab or indent both of these over because they need to be in order to be a part of the for loop. And now I just run it. And I get the exact same result because I did the same thing 4 times over. Now, if we apply a little bit of geometry, we can actually get some really cool shapes. So instead of 4, let's say that I did this 6 times. Now, with what we currently have, right, all it did was trace over the lines that we've already made. But I know a little bit about geometry. I know that all shapes have a total degrees of 360. The only exception being, of course, a triangle. But if I know that 360, say that I want a particular shape, 360 divided by 6 is 60. So let's change our total left to 60. Boom! I now have myself a hexagon. Let's go for a weird shape. Let's go for something with 9 sides. Let's do 360 divided by 9. And it tells us 40, so let's change this to 40. And we get this is called a nonogram because has 9 sides, November, all that jazz. It's called a nonogram. We have a shape with 9 sides. Now, let's expand this to 12. So this would be a dodecagon. So let's do 360 divided by 12. That tells us 30. Here we go. Now we have something that's, another shape with 12 sides. If you can't tell I'm going somewhere with this, this is getting closer and closer to looking like a circle. So why don't we make a circle? Let's, instead of having going forward 100, we'll go forward 3. I only want to turn left 1 degrees, and now at only 1 degrees, I want this to go in range 360. Let's run this and find out what happens. Using very minute turns, we are creating a circle. Now, technically, this is a shape with 360 sides, but for the purposes of anything that we're going to be doing within the turtle program, we've made ourselves a circle here. We've made ourselves a circle where my little turtle goes forward 3 pixels. If I reduce the number of pixels it goes forward by, then I can expect my circle to be much smaller. But it is still going around 360 times. Now, I love the speed that this goes at because it's nice and shows us exactly what's going on. However, it's a little slow. So let's go ahead and set turtle.speed to -1. -1 will tell the computer run as fast as you possibly can. All right, and now we'll see a little bit of an increase in speed, but it really becomes more obvious on the next thing that we're going to be doing. So this is all well and good, right? Let's make something really, really cool. So instead of doing a circle like that, I'm going to say forward and left 90. I'm going to do this the dumb way for right now. Okay, so this will give us a square, right? And now at the very end of this, I'm going to say turtle left 1. So every time it makes a square, it's going to get to the end and it's going to turn 1 degree extra. Let's see how this looks. You can see that we can really start to make some very, very cool patterns doing this. So this is making a square that is walking around the entirety of a circle right now. And we can actually see that it's forming a circle from all of the squares that we see it making. Say that we wanted to be able to see our square a little bit better. Instead of 100, maybe I would do 300. You can see it's still finishing up as it goes all the way around. We'll go ahead and see this shape finish up. Just getting back to the beginning right now. And there we have it, kind of a cool little shape. Now we're going to see how it looks at 300. We can see those lines much more distinctly and clearly between each of our squares as it goes around. This is just one way that we can get a really, really cool shape using the turtle function in combination with for loops. I would encourage you to create your own shapes, use your own shapes. Maybe you don't want to use a square, maybe try using a rectangle instead, maybe use a triangle. Go nuts with it, okay? So this is kind of the really neat thing about coding in Python is experiment, try different things out, see what ends up working, see if you are able to make an even cooler design than what you see here, right? That is all I have for you today on this supplemental lesson. If you have any questions, please let me know, and I hope you are all having a good day.